Hello, welcome to yet another design programming tutorial. My name is Jacob and I'll be taking you through designing reusable code. So basically we're going to be covering functions today. Just an overview, we'll be defining what functions are, we'll be looking at how to write our own functions and how we can refactor using functions. So to start off, basically functions are a way of condensing multiple instructions into one compact module. If you ever open up the P5 editor, you're faced with quite a few functions right away. Let's look at the background function and think about what it's actually doing. The computer doesn't magically know, oh, you've put in the word background and a number, so obviously I have to draw a background with that color. The list of instructions behind background is something like draw a rectangle that is the size of the canvas and fill it with some color. Whenever you look at a function, it has this form, the function name, and then some parentheses. The parentheses are really important because what we put into these parentheses gives us control over the output of a function. So all of the different things we can do inside these parentheses are inputs to parameters. In the case of background, the parameter is just a fill color. We can look at something that's more intense, rect. I'm going to go over to the reference here, looking at rect, and you can see in this example, we have a lot of arguments being put into these parameters. If you scroll down at your reference, you can actually see it lists all of the parameters. So we have an x coordinate, a y coordinate, width, height, and then different radii. So if I wanted to be very particular about drawing a rectangle, I could say I want its x position to be halfway across the width of the screen, its y position to be halfway down, and let's make it 200 by 100, and let's give it 10, 20, 30, and 40 as its radii. Incredible. So this is a highly customizable function, right? We have heaps of inputs to play with. We could think about, what if we want to remove the stroke from this rectangle? I put in no stroke and it takes away the stroke. It doesn't need any customizability because it's just doing a simple task. No input required, right? Just remove the rectangle's ability to make a stroke. We can also think about something like random. So whereas these are about the styling and the output of something that is drawn to the canvas, we also have functions that return a value. So when we put random, some min number, and some maximum number, this is going to give me a return value of something between 0 and 10. If I just press play, nothing happens because we're not using the return value at all. I could make a variable, say potato equal random, and still it's not going to do anything for us. But if I print off potato now, each frame of draw, I'm going to get a new random number, and it's going to print that to my console down here. And if I just wanted 1, I could stop it from looping. No loop also has no argument, no parameters. Cool. There's my incredible potato number. So let's get into how we write our own functions. I think a good way to start learning about functions is to try and recreate something we've already been using lots. We've already talked about background, so let's start there. So background, we said it's drawing a rectangle, filling in a color. The rectangle is defined by the size of our canvas. So let's think about how we can do this. When we want to declare our own function, it looks exactly like these function blocks here. Let's call it BG for background, the important parentheses we always need, and some curly braces. So now we've declared that we're going to make a function called BG, and all of the instructions I write between these curly braces is what will be executed when I call this function. Cool. So let's just try some stuff. We want a rect that is the size of the canvas. So you've got these handy variables, width and height. So that will draw us our rectangle, and the only other thing we have to worry about is a fill, I think. And let's just copy what we have up here. So fill 220 and a rect. Now you might press play and think, well, nothing's happened. But we always have to remember to, once we've declared and given instructions to our function, we have to actually use it. So I'm going to draw it here. Background. And now rect was expecting at least 3 arguments. Of course it was. Obviously we want our rectangle to be starting at the top left corner and to have a width and a height. That is the same as the canvas we created. Cool. You might notice we have an outline here. We don't want that. So I'm going to say no stroke. Cool. Now you might notice for the actual background function that we've been using, we have an argument that we can put in, a parameter for the color. So to add a parameter, we actually use these parentheses here. So it's just like kind of declaring a variable. Let's just make an English spelling of color. Doesn't really matter though, you can call it whatever you want. Let's call it Hank. No, that's not good. Let's call it color. And then we've declared a variable here basically, our parameter, and then we can put it in here. So we said, okay, I want this parameter to be color, and whenever someone types their color in here, red, let's say, then that red will be filled into wherever we've placed this variable name. So now I've created this parameter and I'm putting an argument into it. So we're going to get a horrible red screen. Beautiful. Just like we wanted. I could also put a color in here using our color function, which basically gives us the ability to do RGB values within an argument, a single argument. Whatever, don't know what this color is going to be. It's a beautiful, that color, orange, faded. Sweet. So, we now know how to make our own functions. Let's look at our first challenge. Designing reusable code, the target function. Cool. So, basically this is just saying we're lazy and we want to reuse code. Couldn't agree more. So they've got a target function here. We can draw a function. We can make a function which draws lots of circles overlapping and it looks like a target. Let's look at how this works first. So we have a for loop. We have our index I, and it counts up to some number of circles. And we count from 0 up to that number of circles. And while that's happening, if I modulo 2 equals 0, so this is saying if it's an even number, we're going to fill the circle with white. And if it's an odd number, else, it's going to be black. And then we draw our ellipse at x, y. It has some size. And the size changes depending on which index we're at. Cool. So let's just see what this looks like to start. All right. Cool. We're generating lots of targets. So let's see what they want us to do. We want to achieve 3 simple things. Firstly, actually, it tells us the frame rate set to 10. I think that's a bit fast. I'm just going to set that to 5 just because it's hard on the eyes. Cool. So let's make the targets a different color. So we could think about this a few ways. We could simply, put in a different fill here, and it will be different colors, pink and blue or something. Probably be a nice combo. Cool. We could also get wild with it and have random RGB for... this is maybe going against a bit of the point of having alternating colors here. Because now we don't get alternating, like pink and blue, for example. We get new colors for each thing. So let's go back to whatever colors you want, but keeping these ones consistent. Cool, let's make them appear at different locations on screen. So we could think about changing this here and making some random element here. But I think that would be a bit unintuitive to have this target function that has an x and y input, and then it just makes it random anyway. So let's change it here where we're actually drawing it. So we'll do some random point across the width of the screen and some random point down the height of the screen. So now they should, each time draw function comes around, the draw loop, puts it in a new random position. Cool. Getting pretty psychedelic there. And make them usually appear with more circles. This seems like a slightly ambiguous statement. One way to get them to usually be more than less, let's say that more circles is something more than 3. If we make this circle number argument something bigger, it's more likely the random number picked is going to be higher than 3. So that's one way to do it. We could also think about making a variable let number of circles equal 1 to start, and then do something like, this is maybe overboard, but just for fun, let's do it. If a random number between 0 and 100 is greater than 90, so that's to say if we generate a random number every time the draw loop comes around, and if it's 10% chance of hitting something above 90, right? We want it to take away the number of circles, else num circles plus plus. I guess you could say it's more likely, let's start with 2 so we don't end up with 0 circles, hopefully. It's more likely to create more circles, so we'll usually appear with more circles than we previously had. And put num circles in here. Cricles, as I like to call them. And we can see we're getting more and more circles in our target. I don't know how many it can handle, but it's just gonna more likely than not have more. Cool. So now it's your turn to mess around with functions. Try to do step 2. Pause here to complete the task. Well done. Nailed it. Smashed it out of the park. Let's move on to the next thing. So, applying the weird shape function. So first I'll explain what this weird shape function is by recreating it. Let's delete this old background function. And let's look at a thing called begin shape and end shape. This is sort of a pair of functions that are great for making your own custom shapes. So if you put a list of vertices, corners, points, in between begin and end shape, P5 is going to connect those up for us. So let's have width onto, height onto. So there's a vertex in the middle of our screen. We'll put a vertex at 100, 100, and a vertex at mouse X, mouse Y. Let's see what that does. So it's starting our shape in the center here, drawing another vertex at 100, 100, and then the third vertex, having a bit of fun with it. It's following our mouse. You can see that these lines don't sort of join up. The last line isn't there. If you ever want to do that, there's a particular argument for end shape called close, and that will close up the shape for you. But in the weird function we're going to use for the challenge, we don't need this because we're going to have a fill of 50, I think it is, and no stroke. So it doesn't matter about the stroke closing up because we're still going to be filling the whole shape. Cool, so that's begin shape, end shape. And now for the weird shape function, it's sort of doing this in a function. Let's grab all this and put it in a function. Weird shape. So we're going to keep this fill and no stroke. But now what we want to do is let the person putting in arguments for our function choose where it is on the screen with an X position or a Y position. We want them to be able to give it a certain size, and we also want something else. What do we want? A number of points. Let's just call this points, I guess. I can't remember what it's called, but we'll see soon. Cool. So now we need to think about, depending on how many points the user puts in, we have to be able to draw that amount of vertices. So, looking back to for loops, what we're going to do is create an index, started at the 0th point, and we're going to make it go up to points, the amount of points that the user puts in as an argument. And increment that. And then we're going to create a vertex at X position, Y position. Now let's think about this. If we were to just do this, it would draw however many, let's say, just for an example, let's write in width onto, we want to draw it in the middle, height onto. We want it to have a size of 100, and we want it to have 8 vertices, 8 points. So if we were to just put X position, Y position here, and we had 8 points, it would just draw the vertex at width onto, height onto 8 times. So we need to add some randomness in to get our points sort of spread out. And we've got this handy size parameter, so let's use that. We're going to plus a random point that is kind of within the radius of the defined size. So X position plus some random point from, that radius of size, and same thing in the Y position, in the Y direction. Cool. So now let's see what happens. Incredible. Beautiful stuff. Let's no loop it so we can actually see one example of it. And we're creating some weird shapes, guys. So now that we know that how that works, let's look at step 1. So we're using a nested loop of the weird function, and we're basically trying to make a grid. So we should remember how to make a grid with some nested loops. I'm going to use X and Y because I like X and Y as my width and height sort of variables. Let's see, how many across are we going? 1, 2, 3, 10, and 10 down. So we're going to have it counting from 0 to 9 and incrementing. And let's make that beautiful grid. Y equals 0, y is less than 10, y plus plus. Cool. This is going to be looking very familiar. Now let's think about, we're going to draw lots of weird shapes. So our weird shape needs an x position, a y position, a size, and an amount of points. So these look to have a random amount of points. So, oops, look at that. Beautiful. Hopefully you weren't screaming out for me to close those parentheses earlier, but there we go, save that. So let's do a random number between 3, so we can get a triangle at least, and 10. So for our size, we'll figure out the size when we get to that. And x position, y position. So we want them to follow the grid, right? So let's use our trusty map function. Let x position equal a mapping of x index, which goes from 0 up to 9. And let's create our margins. Let's say like, these look like pretty thin margins. Let's go for 40. From the 40th pixel up to 40 pixels from the end. Width minus 40. And the same thing for the y direction. Y goes from 0 to 9, 40 to height minus 40. Cool. So now, as our index increases, these x position and y positions will conform to the grid. And now let's see what this looks like. Give it a random size of 100. Horrible. Absolutely horrible. So let's do it depending on the size of the screen, and let's say width divided by 50. Awesome. That's pretty much nailed it, I want to say. Not to give myself props, but you know. All right, step 2. Have fun with this. One thing I'll mention about this is when you get to part 3 here, animate the position of the weird shape. You know, if we need to be looping through the draw function and able to animate something, and also our weird shape is being like randomly generated each frame, right? So when you start trying to move it across the screen, it will be it will look like a mess, but I think that's pretty cool, and that's fine. So pause here to complete that task. Cool. Nice work, guys. Moving on to our last step together. Refactoring with functions. Very fun stuff. So refactoring is basically what we did with, well, this has all changed, hasn't it? But remember how we kind of recreated the background function by drawing a rectangle, giving it a fill, and no stroke. We refactored these 3 steps into a background function. So let's do that with a more sort of intense challenge here. We want to clean up the internal structure of the code without changing the output it produces. It improves readability, reusability, and the efficiency. So we're going to be looking for repeated code, and we're going to try to pop that into our brand new function. So we can see here we've got this draw offset ellipse function that we're going to be making, and we want it to end up doing this. Where have I seen that before? Okay. So we can see basically when we draw these ellipses, they have a fill, they're an ellipse, they have some sort of offset from one another, and they're animated to bounce in the y direction. And they have some radius, and the radius is defined up here as 25. So we don't need to worry about that for now. Cool. Let's just start by copying one of these in and seeing if we can generalize. So the fill, obviously, we need a color in here. We've already got a color parameter, so we'll just chuck that in here. Now when we use this function and someone puts in a color here, that color, this argument gets fed through this parameter and it gets popped into here. So we'll be filling with that color. And then we want the ellipse to be, it has some x offset and some y offset. If you notice, these all have the same position of width onto and height onto. So we can put width onto in here, and then we're going to add, some offset. We could minus some offset, but that might be confusing. Better to keep it all positive, and then you can decide if you want to offset it negatively. And then here we want our y offset. And we've got some radius, and that's fine. Our radius is defined up here. That's going to be passed through our function every time because it's a globally declared variable. Sweet, so I feel like we have everything we need here. Let's try to recreate all of these. So our offset for our first one is -75. And we're offsetting by this bounce value in the y direction. And we don't want to color it green. We want it to give it this fill. So again, I'm going to use that color function, which kind of groups it, our arguments all together there. We can do this other ways, but this is good. This works for us. So let's look if we're drawing that first ellipse. Beautiful. It's working. So now all we have to do is do it 4 times for each ellipse. So we've got -25, 25, 75 as our offsets. 25 and 75. Then we're going bounce value 2, then 1, then 2, then 1. 2, 1, 2, 1. How fun is refactoring? It's a copy paste's dream. And we're going to put our fills in. So it might seem arduous to do this, but look how much clearer everything is. I want to draw an offset ellipse, and you know, you can see how everything's working really clear. And it's 4 lines instead of 8. And if we were to draw more and more and more, it's going to be better and better because it's going to be half the amount of lines. There we go. We've recreated that. So have fun doing part 2, and also having a look at your second milestone after that. That's about it from me. Pause here to complete the task, and or don't pause, the video's ending, isn't it? See you guys later.